Hello there, welcome back to the new lecture. So in this lecture we are going to discuss about pressure booster pump selection. Okay? So what is a booster pump? First try to understand. A booster pump is a mechanical device that is used to increase the pressure of water or other fluid, and it also improve the flow rate also. Okay, and booster pump is also known as a pressure pump because it is used to increase the pressure of water. Okay, it is a type of centrifugal pump. You can see in this image here the different types of centrifugal pumps is shown. So booster pump is also a type of centrifugal pump because it uses centrifugal force and one or more impellers to pump the fluid. Okay, so this is the main purpose of booster pump. So here we are going to discuss how to do the selection. It means how to find out the water demand for booster pump and how to calculate the pump head. Okay, because based on this two value you will get the capacity of booster pump from the different manufacturer catalog. So let's start. Here you can see I will show you the schematic of one multi-story building or high-rise building, you can say. Okay, already I have told you about the high-rise building. If your building height is more than 7 stories, so that building is called as a high-rise building. So here we have a multi-story building. This is the schematic diagram of distribution system in respect of gravity system. Okay, for a multi-story building. See, total we have a 20 floor building. You can see ground and up to 20th floor we have. So first our main target is what? We have to distribute the zone. Okay, so how to distribute the zone? So in this NBC only, here I am showing you the NBC reference for this schematic. Okay, in this schematic only I will show you how to do the booster pump sizing. So here you can see zoning of distribution system. The zoning of water distribution network may be adopted for 7 to 9 floor. It means what? In one zoning you have to consider maximum 9 floor. So here we have a 20 floor building, you can see. Okay, first try to understand this thing. Here see what happened. Here we have taken the raw water tank, underground raw water tank. Okay, so the water will coming from the suppose municipality line. So first of all we have to treat this water. Why? Because here some impurities also there. So that is why what we are doing, this raw water tank sometime we are using directly also, but if you want to treat, so you need, here we need the water treatment plant. So from raw water tank water we are supplying to the water treatment plant. Okay, so here we have to treat the water and then that treated water we are supplying to the treated water tank again. Now what we are doing, this you can see the orange piping layout. From the treated water tank we are supplying water with the help of pump. See this orange color line piping to the domestic water overhead tank. Here we have taken two separate tank. First tank for domestic water overhead tank and second is our flushing water overhead tank. Remember why we have taken separate, because here we have to reuse the sewage treatment water also, sewage water. That is why we are taking separate water. So see here you can see the treated water storage tank we have taken, which is coming from sewage treatment plant. Okay, suppose the water which is running, all of you know, if you the water which is running in soil pipe, waste pipe, if you want to treat that pipe in drainage system, generally the wastewater which is running in soil pipe and waste pipe, if you want to treat that water, so for that we need a sewage treatment plant. From the sewage treatment plant, that water we are collecting in this treated water storage tank, which is coming from the sewage treatment plant. Now this water you can use only for irrigation purpose, or if you want to use for flushing purpose, okay, that also you can use, or for gardening purpose you can use that water. So that is why we have taken separate flush overhead tank for this water to reuse this water. So from the treated water storage tank, we are supplying water to the flush tank. Okay, now you can use for flushing purpose. If you want to flush So you can take the water from the flushing water overhead tank, okay, for the flush. And this domestic water, we are using this water for what purpose? For bathing purpose, for washing purpose, for many other, okay. So now see here what we have done. Okay, we have created three zones. See, zone 1, zone 2, zone 2, we have taken 17 to ninth floor. Okay, zone 1, this top 3 floor we have considered as a zone 1, zone 3. Now remember, the top 3 floor, here we do not get that much pressure which we need for our fixture. Now the question is, from where we get that how much pressure we have to maintain for fixture. Suppose if you have a wash basin, so how much pressure we need for wash basin minimum, for water closet. So when you open the international plumbing code, here I have international plumbing code uh, 2021. So in that, when you open the table of content, here you will get the detail. You can see in this table of content, when you scroll down, see here we have one topic, water supply and distribution 6.1. So open it where it is 6.1. So in this only, just little bit, yeah. When you open the page number, I think 59, so you can see here you will get one table. So water distribution system design criteria, required capacity at fixture supply pipe outlet. In column first, you can see the fixture supply outlet serving is given. If it is a drinking fountain, so how much minimum flow rate you have to maintain for drinking fountain, it is given 0.75. How much flow pressure you have to maintain, minimum 8 psi. Okay, so suppose in our top 3 floor we are not getting that much of pressure. Suppose any fixture is coming, we are not getting. See, the for water closet here, the flow and flow pressure is given, minimum that much we have to maintain. Okay, so what we are doing for this top 3 floor, here we have taken the booster pump to maintain the pressure level in this top 3 floor, 20th, 19th and 18th floor. It is written here, booster pump for top 3 floor ring main. So here we are creating a loop or ring main to reduce the pressure level, because all of you know, when here we have you have taken the booster pump, so you will get more pressure. So better is to create a loop to reduce the pressure, to distribute the pressure. Then from this loop, see, we are serving water. You can see this a loop, a blue color loop. Here we are supplying water with the help of booster pump, only this 3 floor, 20th floor, 19th floor and 18th floor. Okay, and for remaining 17, 16 and whatever floor are there, here we have got that much of pressure. That is why we are not supplying, we are not using booster pump for that remaining floor. Getting? So to maintain the pressure in this 3 floor, 20th, 19th, 18th floor, we have taken booster pump. So now what we have to do? So here I will show you the complete 3 floor detail. See, here you will get the schematic of water supply system. From here also you can open it. Okay, so here I have taken this 3 floor detail, 18 floor, because this booster pump we have selected for this 3 floor only na. We have to maintain the pressure in this 18th floor, 19th floor and 20th floor. So here you can see the roof tank is given. From the roof tank, because we know that if the tank whatever, if you have a floor nearest to this tank, so what happened, that much of pressure you will not get. Okay, when you go far from this tank, so you will get the pressure will increase. So here you can see the from roof tank we have installed the booster pump, everything is given. Always if you want to do the calculation, so what we have to do, if you want to find out the friction loss in pipe, so always we have to consider the longest pipe route, that I will discuss. First try to understand. See, each floor height is given 12 feet. Okay, 18th floor, 19th floor, and see in each floor we have one water closet, one kitchen sink, one urinal, one wash basin, one shower and one laundry. Even here you can see the slab thickness is also given 0.5 feet and everything is given. Okay, now come to our calculation. Okay, so in this calculation, Before doing the calculation, I will show you. We need to calculate the pump head. So all of you know head of how to calculate the pump head. Static head, residual head plus friction loss in pipe head. Then we have to calculate the friction loss in fitting and valve head. Okay, static head, that means the vertical length of pipe against the gravity. Okay, residual has the pressure acting at a point in a system, that already I have shown you. For water closet we have a different minimum pressure we have to maintain. For flush valve, that all we have to see. Okay, so now before that I have told you, here we have to calculate the water demand first of all. So open this first tab, water demand. Here you can see I have taken the table. This table, whatever, if you want to find out the water demand, so first of all we have to calculate the fixture unit for cold water and for hot water, because based on fixture unit only you will get the how much water we need to supply. So this reference I have taken from International Plumbing Code. You can see here we have a fixture, some fixture is written. Okay, if you are designing for public, so for cold water you have to consider this one to find out the fixture unit. For water closet flush valve type C, the fixture unit is given 10. For water closet flush tank type 5 for public. Okay, for private when you come, so you will get the different value here. Okay, so suppose here we are designing for public. Okay, so that is why here I have taken the table for public. Everything fixture unit is written. If you want to see this detail from where I have taken, so see I'm opening my International Plumbing Code. Here you can see in IPC only, you have to just scroll down and open Appendix E. When you open the Appendix E, here you will get the detail whatever I have taken. Just wait, see, here you will get the detail. Appendix E, see, from page number, I think. Okay, see, page number 173 in this table number 103. Here based on a fixture unit you will get the demand value. If you want to see the fixture unit, just scroll down. Here you can see for bathroom group, if you are designing for private flush tank type, so you have to take the fixture unit for cold water 2.7. okay, for bidet same thing. When you come here for water closet, suppose we have a water closet public type, we are designing for public flush tank type of water closet. So see how much fixture unit we have to take for cold water, 5. Because in case of water flow, water closet don't need to take the hot water, only we are supplying cold water na? So 5. Same way here also, when you see the Excel sheet which I have taken for water closet flush tank type, how much, 5. So this reference I have taken from International Plumbing Code. Okay, now again when you come, once you will know the fixture unit, so when you scroll down in next table, here you will get the table for estimated demand based on fixture unit, water supply fixture unit. Here you will get the demand in gallon per minutes or in cubic feet per minute. But remember here 2.2 condition is given. Supply system predominantly for flush tank and flushometer valve. If you are using flush tank, so prefer this one, and if you are using flushometer, so we have to prefer this thing. Okay, now open your Excel sheet. Here also you can see same thing I have taken, what based on your water supply fixture unit, demand is given here for flush tank, for flush valve. Okay, so here I have applied the formula. Only you have to enter the quantity to find out the demand value. So when you come here in this drawing, just we need to find out the total water demand, how much water we need to supply from with the help of this booster pump. So just calculate. See, in each floor we have one water closet, so here we have a 3 floor. So 3 water closet, 3 kitchen sink, 3 urinal, 3 wash basin, 3 shower, 3 laundry. So come here and write down. So suppose water closet, we have a flush tank type of water closet, quantity 3. When you enter the quantity, see automatically here you will get the total fixture unit for cold water, for hot water and GPM. As per that, automatically they will select. Okay, because here we have taken the formula. Now okay, 3 water closet and 3 laboratory means wash basin, then we have a 3 kitchen sink, then 3 laundry, After that, urinal flush tank type 3. Only 5 fixtures are there. Come here in drawing and see. No, we have one wash basin, one shower. Okay, shower we have taken or not? No, so write down 3 shower total. So as per that, see, you will get the total demand 33. It means to supply with the help of booster pump, how much water we need for this 3 floor, 33.8 GPM. So in calculation, come here. Here everything I have written. Okay, to find out the here we have got the total demand. Okay, so in this way we have to calculate the total demand value. Now we have to calculate the head of pump, head of this booster pump, because if you want to find out the selection, for the selection of booster pump we need two things: total demand and pump head calculation. Okay, as per that we have a different catalog. You will get the model number and everything of that pump. So to calculate the head of pump, static head, residual head. So first of all, I will show you how to calculate the friction loss in pipe. Okay. So which type of pipe? From here you can select the material. Suppose we are using copper pipe. Okay. So for that C value is 150. Remember, if you want to find out the friction loss, so here we have to use the Hazen-Williams equation, or many other equation are given. So here I am using this Hazen-Williams equation. To find out the losses in pipe, you can see the formula: P is equal to 4.52 Q to the power 1.85 divided by C to the power 1.85, then D to the power 4.87. Here P is frictional resistance in PSI per foot of pipe, Q is flow in GPM, C frictional loss coefficient, and D is actual internal diameter in inches. Okay. Now the question is, from where you will get the friction loss coefficient value, C value. So this value is totally depends on which type of material you are using for pipe. When you open this table, just scroll down. Hazen-Williams C value is given. Suppose if you are using copper tube pipe, so for that C value, how much we have to take? 150. Okay, so assume that we are using 150 only copper tube pipe. Okay, generally in water supply system we are using copper pipe only. So okay, C value you will get from here. Now come to your calculation. Same way, here first of all you have to write down the flow value. So in drawing, come here from node A to B. See, the length of pipe is given 5 feet and it is the suction line of pump. So some fitting will also come, like flexible connection. In suction line we have to place the flexible connection, and strainer also to strain the debris, unwanted particles, and then finally gate valve. If you want to close the, so you can close it manually also. So for that also we have to take. So here in calculation you can write down which type of fitting is coming. Otherwise what you can do, in last, what you can do, only calculate the friction loss in pipe. In last you can take add 30% for fitting and valves. Okay, as per that we have to design. Okay, because here every fitting is not given, so just consider that 30% is enough for fitting. Okay, so I am doing the calculation now. So first of all we are going to start from here A to B. So total pipe length 5 feet, and flow value total we have calculated 33.8. So I am writing here 33.8 GPM. So when you write the flow value in GPM, automatically it will convert it into meter cube per second, because I have applied the formula here, you can see, to convert the flow in GPM. Now we have to find out the diameter. So in meter, okay, first of all, then I will convert in inches, because velocity, all of you know, for gravity pipe, this is our gravity pipe now, how down take, or you can say gravity pipe. So for gravity pipe always we have to maintain 0.4 to 0.8 meter per second velocity, but the recommended is 0.6 meter per second. Okay, so here I am writing 0.6 meter per second. As per that you will get the diameter in meter, 0.067. So you can convert it in inches, because if you want to calculate the friction loss in psi per feet, so you have to convert the diameter in inches. So I have converted, see, you have to multiply by 39.37, so 2.65 inches. Getting? So in this we have to, and pipe length, it is given total A to B 5 feet. So I am writing 5 feet. See, here we got the friction loss. See here, same formula I have applied, Hazen-Williams equation formula. If you see here, 4.52, then q to the power 1.85, then whatever material you have selected, C value to power 1.87, then diameter D12, see, 2.6 to the power 4.87. So you will get the friction loss value in pipe, in per feet of pipe length, how much? 0.0025, but our total pipe length is 5. So as per that, just multiply both of them, you will get 0.0125. Come to next one now. Again, C to D. Now C to D. So for C to D, pipe length is 5 feet, 6 feet, 11. Okay, 11 plus this one 0.5 feet slab thickness also you have to take, 0.5 again plus 10.8 feet, this one. So total is 22.3 feet. Okay, pipe length and flow value is same. So come here, write down 33.8 flow value. Velocity we have to maintain 0.6. As per that you will get the diameter, and pipe is 22.3 feet. Getting? So as per that you will get the head loss or pressure or friction loss in psi. See, now come to next one, DE section, D to E. So total pipe length is what? 0.65 plus slab thickness 0.5 plus floor height 10.8. Okay, total is 11.95 D to E. But here the flow rate will reduce now, because see, we are now supplying water to the 19th floor. So some water already we have supply in this 20th floor. So just minus it. So whatever in water demand we have taken 3 water closet, 3 kitchen sink, 3 total. So minus one of them. Come here in water. Now we have remaining 2 to shower, to kitchen sink, to laundry, and to urinal. So for that 26.6 GPM. So write down 26.6 GPM water, and here velocity we have to maintain 0.6 only. As per that, see, you will get the diameter, and total length of pipe is 11.95 feet. As per that you will get the friction loss value. Now come to next note, E to F. So total length of this 0.65 plus thickness of this slab and 10.8, same 11.95. Okay, but here also flow will reduce, because now only remaining flow, how much? One water closet, one kitchen, that much flow will. So in water demand, now you can just write down 1. So for that, see, 15.2 GPM is coming. So write down 15.2 GPM, and 0.6 meter per second velocity we have to maintain. And here see, for diameter I have written the formula. We know that Q is equal to AV. To find out the diameter, A is equal to Q upon V. So area of circle pi by 4 d square. As per that you will get the diameter. Okay, now write down your length. See, now come to next one. Again in drawing the remaining, always as I told you, to find out the friction loss we have to consider the longest pipe route. Why? So that is why I am considering the longest pipe route up to here, water closet. Because whatever pump you have selected, if this pump is capable to supply the water in this farthest fixture, it means they can supply the water to each and every floor. So, but here you have to know that how much pressure you need minimum in this farthest unit. So that you will get from the International Plumbing Code, that I will show you. So okay, so from F to G, how much? 7, 7, 14, then 7, 21, 26 total, 26. And flow already I have written, I think 15.2 only GPM, and velocity we have to maintain 0.6. So how much now? 21, 26 total pipeline. So as per that, see, here you will get the uh, friction loss total. How much? 0.254 psi something. Now we have to add, you have to add the 30%. as general practice for fitting and valve losses. So 30% when you add, you will get 0.33 something psi. So here I have written friction losses in pipe and fitting, how much? 0.33 psi. Now if you want to convert this psi in bar or anything, you can see the conversion formula I have written here. You can convert it. So okay, so we have calculated the friction loss in pipe and fitting. Now again, to find out the pump head, we need to static head, residual head. So residual pressure or residual head is what? The pressure acting at a point in a system when flow being delivered. So here in this drawing, you can see the last fixture is what? Water closet, flush tank type. So how much minimum pressure we have to maintain? So in IPC, you will get the detail. Minimum pressure we have to maintain here. When you open the page number, I think 50, 60, what? 61. 1 minute, huh? Okay. So here you can see the detail is given. See, for water closet, flush tank type of water closet, suppose if you are considering, because flushometer valve type is also available. So for water closet, flushometer tank, see, minimum flow pressure is given 20 psi, that much we have to maintain. So in our farthest unit, whatever your minimum, we need to supply 20 pressure, how much we have to maintain? 20 psi. So what you can do from here, just write down 20 psi residual pressure, 20 psi. Okay, that much we have to maintain minimum. Static head, as I told you, that is the vertical length of pipe against the gravity. So when you come in this drawing, already we have installed the booster pump in terrace. Suppose if you have installed in ground floor, on that time we have to take the, we have to consider the vertical. Here only just little bit, only 2 to 3 feet vertical pipe is going. So just consider 3 feet. 3 feet is enough. Okay, now come here. Suppose the vertical pipe length is 3 feet. So in calculation, I want the value in psi. So 3 feet, to convert the 3 feet of water column in psi, what you can do? See, the conversion formula is written. 3 feet multiplied by 0.434. So you will get around 1.3 psi. So I am writing just little bit, okay? Because here generally we have placed in the terrace only. So as per that, see, total pressure head, how much we get? 21.63 as per this fixture total. So here I am writing pump pressure head is 21.63 psi. You can convert it into bar and whatever. And pump flow capacity, how much we have calculated total? You can see 33.8 na total. So here I am writing 33.8 GPM, gallon per minute. This is our total pump flow capacity and pump pressure head. Now this two detail you have to submit to the manufacturer. They will give you as per that catalog, you can select the model number and what. So as a designer, we have to calculate this two value. Okay. So in this way, we have to do the booster pump selection. So I hope that all of you enjoy this session. See you in next one.